Hello students. In the last lecture we have started with the data transfer instructions, and in that the first standard format already we have studied, and that is what? Move RD comma RS. So in this case what we have seen, the contents of source register will be copied to the contents of destination register, and with this standard format for us it is possible to generate multiple instructions like move A comma B. So the function of this instruction will be what? The contents of B will be copied to A. Similarly, we can generate another instruction like move B comma A, move C comma A. So with A as a source register we can form many instructions. With B as a source register we can form many instructions like move C comma B and so on. So with this standard format it is possible for us to generate multiple instructions. So today we are going to start with the next standard format. Okay. So today we are going to start with the next standard format, that is MVI RD comma 8-bit data. So what is this instruction? MVI space RD means destination register comma 8-bit data. So this data will be the operand or it may be the memory address. Okay. So for example, see here, I will write the instruction MVI A comma 32H. So in the last lecture I have already told you that what is the meaning of H. So H is what? H here represents this as a hexadecimal number. So 32 in this case is not the decimal number, but it is a hexadecimal number. So to indicate this one, we are going to write the H here, because we have seen that in case of assembly language we are going to use hexadecimal coding. Okay. So in this instruction MV, so MV, this part is nothing but the shortcut of movement. So move immediate number. So I here stands for immediate number. Immediate number means what? The number which is already present in the instruction. The number which is already present in the instruction. So the meaning is what? Move immediate number which is present in the instruction into the destination register. So in this example the destination register is accumulator. In this example the destination register is accumulator. So in the last lecture we have also discussed about the classification of instruction set depending upon the size, right? So in this case, to store this instruction we require two memory locations because it is a 2-byte instruction. See how it is. We know that each and every instruction will be having a unique code. So in this case MVI A will be having a unique code because it is a separate operation. Suppose if I am going to write MVI B comma 32H. So what it indicates? Now this immediate number has to be copied in B. So MVI A is different than MVI B. Likewise, MVI B is different than MVI C and so on. So each and every instruction is different from each other and they are going to perform the different tasks. So here in case of MVI A, we are going to write its hex code. Okay. So the first part of the instruction, I have told you that this part is called as what? This part is called as opcode. No, sorry, mnemonics. This part is called as what? Mnemonics. And this part is called as what? Operand. This is called as what? Operand part, right? So we should know that for each mnemonics will be having one unique hexadecimal code. So in this case for MVI that hexadecimal code is 3EH. Okay. We have seen that there are 246 instructions in case of 8085 and each and every instruction will be having its separate operational code. So this is a opcode. This is a opcode for what? For MVI A. So we need to require one memory location to store the opcode of MVI A. And next, this is what the operand, because 32 is the data here. This is the operand and we need to move this operand in accumulator. So we need to write after 32H. Okay. So let's see how this instruction will be stored in memory. Let's see, already I have told you that what is memory. Memory is nothing but it is just like a page of a notebook. Okay. And each line is nothing but, here each line is nothing but what? Single memory location. Suppose the address of this particular location is 0001H. So the next address will be what? 0002H. So these are the addresses. These are the addresses. Okay. Right. So to store this instruction, as this is a 2 byte instruction, we are going to see here how the instruction will be stored. Suppose the controller is starting to save the instructions from the location 0001H. So again here it is not a decimal number, where it is a hexadecimal number. So what will do the controller? So processor. So processor will store 3E at this first location and 32 at the next location. See here, when you are going to write the instruction, so if the number of codes used by the instruction are more than 1, then in that case each instruction will be stored like this. So opcode will be stored first, and in the very next location the next data which is coming in the instruction, that will be stored. So that's why this is called as 2 byte instruction, because this is using 2 memory locations in this case. So in this example we have seen that the opcode will be stored in the first location, that is 0001H, and the next number which is there, it is here 0002H. So address for this will be 2. Okay. And suppose now you want to write the next instruction. Suppose after this I am going to write MVIB, 72H. Okay. So now this instruction will be stored from the next location. So 0003H will be the next location. So in this case, suppose MVIB, the code for MVIB will be 4EH. Okay. So 4E will be stored where? 4E will be stored here, and the next data will be stored here. So likewise the next instruction will be stored. So in the memory, the storing of the data will take place like this. Okay. So at this point we need to remember that in case of 2 byte instruction, the processor is going to use the memory locations, 2 memory locations to store the instruction. So in this instruction we can see here that move immediate number in accumulator, which is a 2 byte instruction. So in this example, after execution, A will be loaded with 32H. So similarly in this instruction, what will happen? Move immediate number 72 in B register. So after the execution, B will be loaded with 72H. So in the same way, we can write the instructions like MVIC, suppose 44H. So after execution, C will become 44H, right? We can also write the instruction MVID, 22H. We can write the instruction MVIE, 78H. We can write the instruction MVIH, suppose 11H. Then MVIL, 02H. Okay. So using each and every instruction, we can write the using each and every register, we can write this instruction. So MVIRD, 8-bit data is the standard format, and using this standard format, we can generate multiple instruction. Using this standard format, we can generate multiple instruction. Okay. So in the next video, we are going to study the next standard format from the data transfer group. Okay. So today we are going to stop here. We'll meet in the next video with the next standard format. Thank you.